Hello everybody. Sorry again that I couldn't be here today, but I did want to go over with you more on the 2.23 heat loss from the utility shed transmission load worksheet. So I know that you probably started on the notes and you hopefully got that assignment done and submitted. And now you've moved on to the transmission load worksheet. I'm going to try and make this work where I kind of go over the first problem with you that will hopefully then explain everything that you'll be doing for the assignment itself. So I have it opened over here. Again, I need you to pay attention to these assume the following bits because they're just as important. You need to remember them. So remember those, please. But you can see you're going to need the PowerPoint, you're going to need the R value density chart, and you're going to need drawing 1A. Honestly, you're not going to need the engineering weather data because for the temperature differential, we'll go over the answer, and that answer will be consistent for the rest of the problems as well. So the first thing you have to do is calculate R value, and if we open up that PowerPoint, I want to show you what it says specifically. Okay, so there we go. R value. This is the example in the PowerPoint. This is not the example that we are doing on the worksheet. So it says we can obtain the U factor by calculating the R value of the wall assembly and then taking the reciprocal. To find the R value of the wall assembly, simply sum the R value of the wall components right here. Over on your example, they do that for you. And they say calculate the total R value for each surface, including the four walls, the doors, and the windows, and the ceiling and the roof. Up here it says the floor will be ignored. Use the R value chart to find the R value for the individual layers within the wall. So if we go to the R value chart right here and we look at our individual layers, we've got wood beveled siding. So let's look at siding. Wood shingles, no. Wood drop, no. Wood bevel, 3/4 inch by 10 inch. Perfect. The R value for that is 1.05. Yay. Wood sheathing. We look for wood sheathing. Oh, here we go. OSB low density. OSB low density. Now, the R value here is 1.41 and they have 0.7. If you look, we're using a 1/2 inch thick and this is per inch. So they had to divide it by 2 to get the R value for the wood sheathing for our problem. And then you continue down. And where they got all of these pieces is from the drawing itself. Remember that broken out section of the drawing 1A, you can see it breaks down all the different components of the wall. You will need this also to do the roof because it breaks down the roof and you'll have to go through this process again. So basically here they go through everything for you. They add them all up to get an R value of 14.13. Now the best part of this is, oh no, why does it look like that? Oh well, not that big of a deal. The R value down here is going to be the same for all of the walls because they're all made of the same material. The only time it's going to change is when we get to the ceiling, doors, and roof. They're going to have a different R value. Now, it said in our PowerPoint that we take the reciprocal to find the U factor, the reciprocal of R to find the U factor. So, to do that, that's step 2. There we go. So, in the PowerPoint, it takes U equals 1 divided by the R value. So over here, for U factor, we're going to take U this is definitely not thick enough. This is fine, but I'll just have to do. Okay, so U equals 1 divided by 14.13. So if I take my calculator and I take 1 divided by 14.13, that gives me a answer of 0.0707714 and going on. But if we read, it says, when R values are converted to U factor, at least the first 3 decimals must be used. Do not round the third digit. So that gives me, if I look at my answer again, it equals 0.7, oh, nope, 0.070. The first 3 numbers. So I put that in here. 0.070. Cool. U factor done. Now we calculate the area. You're again going to have to go back to this right here to figure out we are on the west wall, so we can go and look at the west wall. We know from floor to ceiling, the top of the floor to the ceiling is 8 feet, and we know the length of this utility shed is 16. So for this, I'm just going to go in and take area equals 8 times 16. Which gives me an answer of 128. Now, I have that answer. If we look at our west wall has 0 windows and 0 doors, so we don't have to take them into consideration. But if we look at our east wall, we have windows. So we have to find the area of the windows, of the 2 windows total, and subtract it from the square footage of that wall to get the precise area for the east wall. And then the same for the south wall, it has a door. Temperature differential. This is the one that you would use the example weather data, but I'm not having you, because in the problem itself, it gives you the answer, and it's the same for every row. So if you look down here, find the design temperature differential between the desired inside temperature and outside winter design. Basically, our desired inside, if we look at the top again, our desired inside temperature is 70 degrees, and then we would use that chart to find the outside temperature of Boston, Massachusetts in the winter. But they give it to us. The outside temperature of Boston, Massachusetts in the winter is 9 degrees Fahrenheit. So we take 70 minus 9 degrees, and that equals 61. So we hit 61. Now this is where my... See, I could actually file. Let me add that back in so that you can see clearly. Now, for temperature differential, for transmission load, we are now going to take all of those things we just calculated and replug them in. So this is 61, this is 128, we got 0.07, sorry, my handwriting is a little atrocious. But now we need to calculate all that information. And if we go back to our PowerPoint, because it goes over how to do that, the note that it has is note that we only consider the heat loss / gain caused by the transmission of heat through the building components. Other causes of heat loss or gain, such as lighting, people, equipment, air filtration, are not considered. Therefore, our purpose when we refer to heat loss and heat gain, we are referring to the heat loss and heat gain caused by transmission. So now that we've cleared that up, this is how we would go about it. So we're going to take Q equals UA delta. So if I were to go back in and throw in my units, that's delta T, square footage is feet squared, and then R is fine. We can leave R the same, I think. Oh, well, sorry, U factor is, let's see if I can erase this really quick. Oops. Not going to be able to do that. Let's just go over it in white. There. Okay, so we said the U was 0.070, and then if I put those little, it's CTU over F. You guys get it. It's right here. Put that in there. I can't fit it, so I'm not going to try. We need all that information to then help us calculate. Okay, so let's work through this, shall we? So Q equals 128 feet (0.070) and then 61 degrees Fahrenheit. Once you cross out all of your unneeded units, we can then calculate by multiplying 128 times 128 times 0.07 times 61. And then it says here, you may round the transmission load to the nearest whole number. So I got an answer of 546.56. So if I round to the nearest whole number, 547. So 547. Don't forget your units, BTU. Hour, 61 goes all the way down. 14 goes to here. So our U factor is the same to here. This is where it gets different because they're different walls. The square footage is going to be slightly different just because of your windows and such. So your transmission loads are going to be different. So that was all that I needed to go over for the transmission load worksheet. You should be able to get that done now. Since I'm not here, make sure you get the heat loss and heat gain worksheet submitted, as well as the transmission load worksheet submitted by the weekend. This will be here for you. You can come and view this whenever you need. If you are in class and you'd like to grab a hard copy, I have them on my desk. You can go grab one if you'd like. Otherwise, if you have any questions, please feel free to shoot me a Schoology message. Again, I'm not the best at answering on the weekend because technically I don't have to work on the weekend. But I will be here Friday, so you can definitely shoot me a Schoology message and I'll get back to you on Friday. Otherwise, have a great weekend and I'll see you guys next week.